Hello guys. So yesterday you should have done the lesson on piecewise functions. We're going to be also graphing piecewise functions today, but we're going to be focusing on a topic called continuity. And we'll be doing this for 2 days. That's why today is called part 1. So we're going to talk about what does continuity mean. I'm going to just summarize it real simply right now. Continuity means you can draw or trace the entire graph without picking up your pencil. If to draw your graph you have to pick up your pencil to draw one section, then another, it's not continuous. Can you tell if a function is continuous at a given point? This is going to be the first group of exercises in the assignment. Can you tell if a function is discontinuous? By looking at its graph. That's the second part of the function, by the way. Discontinuity is the opposite of continuity, so that's discontinuous. And then we're also going to be looking at types of discontinuity. That's going to come up in the second part of the graph as well. Or second part of the assignment as well. So, because we're doing piecewise functions, I want to have Desmos handy. And there's the same problem from yesterday right there still in my calculator. All right. So, do I have anything else? Oh, the types of discontinuity. There is something called jump discontinuity, point discontinuity, infinite discontinuity, and gap discontinuity. We are going to cover these two today. We're going to talk about these two tomorrow. Maybe I could spell tomorrow. Oh gosh. The day after today. Tomorrow. I'm doubting whether I spelled that right. Gap discontinuity is a thing, but we don't cover it. And it's not, even if you went to college, it wouldn't be a big deal. So, even if you went to college math to study this, gap discontinuity would not be a big deal. Okay, so as normal, I'll do the evens. I ask you to do the odds. Determine if each function is continuous at the given x value. If it is not continuous, classify the discontinuity. So, okay, this types of discontinuity is going to come in the first and second portion of the assignment. So let's graph this. Now notice there's no graph paper here, so you do not have to recreate or redraw the graph. All you have to do is have it on a calculator to look at. So y equals negative x minus 6. Then I got to get my little brace in there to type in the domain x less than or equal to 0. And then the second piece, y equals 2x plus 3, plus 3, get my little brace in there, x greater than 0. Okay, would it be possible to draw or trace this graph without picking up your pencil? No. If you're doing the green, you get to here, then you have to pick up your pencil and jump up here to purple in order to keep drawing this. So, is this continuous at the point 0? No. Oops. And because you jump from one y value to another y value, this is called a jump discontinuity. So let's check number 2. The answer is, oh, well, they didn't actually say no. I guess if you call it a jump discontinuity, then it's automatically a no. So you jump from one portion of the graph to the other, it's discontinuous. All right, let's look at number 4. Now, this one is not a piecewise function. It's y equals x cubed minus 2x squared minus 1. So that is a cubic function. We have to look at the point 1. So the x value 1. So when I get to the x value 1, oh my gosh, this thing's acting crazy. The point is, can I draw right through here without picking up my pencil? And the answer is yes, I can. You can totally draw that. You don't need to pick up your finger if you're tracing it on the screen, or a pencil if you're drawing it on paper. So this is continuous at x equals 1. Is that what the answer is? Number 4, yep, continuous at x equals 1. Number 2 was no, it had a jump discontinuity. Let's look at number 6. Y equals negative 2x plus 5. Oh, forgot the 2. Negative 2x plus 5. Brace x less than 1. Where is that? Okay. And then y equals 2x plus 1. Get the brace in there for my domain, x greater than or equal to 1. All right, so we have 2 pieces here. This one ends in an open circle, but this one begins at the same point in a closed circle, so it fills that gap. So this can be drawn without picking up your pencil. It is continuous at x equals 1. So number 6, continuous at x equals 1, right there. So it was a piecewise function. You cannot just automatically assume piecewise functions are going to be discontinuous, because sometimes one piece picks up where the other piece leaves off. So that would still be continuous. Let's look at number 8. Y equals negative x squared minus 2x minus 1 at the domain x less than or equal to negative 3. Oop, there was a 2 there. So that looks like this. Kind of a weird parabola kind of a shape. Kind of a parabolas are normally more curvy than that, but yeah, whatever. Okay, the second piece is y equals negative 1, and my domain is x greater than negative 3. Okay, can you see that to get from one piece to another, you would have to jump from here up to there? So this is jump discontinuity at x equals negative 3. Let's check number 8. There it is. Jump discontinuity at x equals negative 3. So, no work to show. Sorry, getting a notification of a meeting that's not going to happen today. No work to show. You're just going to have to do this on, excuse me, on Desmos and analyze it yourself. Let's do number 10. So y equals x squared plus 6x plus 9. Now, x not equal to 5. There is no not equal to sign on this keyboard. So that means that this piece is actually 2 pieces. Not equal to basically means this. It means x is less than 5 and x is greater than 5. So if x does not equal 5, I'm sorry, negative 5, my bad. Those are both supposed to be negative 5s. So I need to type this in twice, unfortunately. X less than negative 5. Then I need to type the exact same one in. Y equals x squared plus 6x plus 9. Well, I wish there was a copy and paste here. X greater than negative 5. And so, yeah, that's, oh, I typed it in wrong. There's supposed to be a 6 there. There we go. And then y equals negative 1 on the domain x equals negative 5. Now remember, this is a single point, and Desmos can sometimes be funny in graphing a single point. So let's look at this. I trace the black line, and it ends in a circle. I trace the red line, and it ends in a circle. And where is this final point at? This final point is at negative 5, negative 1. Negative 5, negative 1, is that going to be filling that circle? -5, -1? No, -5, -1 is going to be down here in this quadrant, right? So it looks like what we have is, I told you didn't have to draw your graph on your paper, but I need to do some drawing. It looks like our picture looks basically like this, that there's two pieces of the same parabola and then that point is somewhere else. Now, this is what type of discontinuity is this? It's clearly discontinuity. You cannot draw this without picking up your pencil. You have to pick it up to put this extra dot down. So this is discontinuous. So discontinuity at x equals -5. But let's see what this one is called. Number 10, where am I? This is called a point discontinuity. So the reason it's called a point discontinuity is because there is one single hole, one single point in the graph that's not there. You don't have to jump from like one y value down to another y value. This represents a jump, like in those other problems. This, to get from here to here, you're just skipping over a single point. So this is called point discontinuity. So a point discontinuity is kind of like what you might call a hole in the graph. All right, so this one was a jump because it went from one level to another level. There was a jump there. This was continuous because it was connected. This was continuous because even though it was piecewise, the two pieces connected each other together. This was a jump because one let off and then it picked up somewhere else. Again, there was a jump from one to another. That drawing was horrible. This one is what we call a point discontinuity because a single point is removed. Okay, now, for the rest of the paper, it's kind of the same thing, but you need to tell whether there's any discontinuity anywhere on the graph. So number 12 is a parabola. And generally speaking, all parabolas are always continuous. There's no disconnect anywhere. I'm still going to graph it to show you. Doggone it, I'm having all sorts of issues here. There's supposed to be a minus sign and a 2 and then a +1. Okay, so here's my parabola. And you can trace this. There's going to be a point everywhere. There's no gaps, no holes, no jumps, no spaces anywhere. This is continuous, the entire function. There's no single point anywhere. So there you go. Number 12 is continuous. Let's look at number 14. Y equals -2x minus 5. And then the domain is x less than or equal to -3. So we have a slanted line. And then second piece, y equals -x over 2. This is what we call a rational function, +1. And my domain is x greater than 3. -3, sorry. And clearly those do not connect each other. So it appears there is a jump discontinuity. And where does that happen at? -3. Let's check number 14. Jump discontinuity at -3 right there. All right, 2 more and we're done. Number 16. Y equals 2x plus 7. Now, there's no work to show here. And it'd probably be very, very tempting to just copy the answers. I understand that. Please do your diligence in typing this into Desmos. It's worth the practice, and it's worth developing the observation skills to see that you can, correctly analyze these graphs. And that is what we're doing here. We're doing an analysis, and it is a type of higher level thinking. So Don't just gloss over this. Okay. Are these graphs connected? No. There is a jump discontinuity. I'm going to write jump discon, just to be lazy, at, and where does that happen? X equals -5. So there's number 16. Let's look at 18. Oh wait, sorry, the answer to number 16. There it is. 18. Y equals -x squared minus 8x minus 16, bracket x less than -5, and y equals x minus 2, bracket, or brace, they're not brackets. Why do I always say that wrong? -5. And clearly there is another discontinuity. It is a jump at -5. So jump discontinuity at x equals -5. And there it is. So it looks like, and just cruising through, there's a lot of jump discontinuities, some continuities, and then a couple point discontinuities. So, oh, number 10. Yeah, that was that point discontinuity. So do your best on this. Get the practice of graphing Desmos. Make the analysis. Do your answers. Please don't just copy the answers. Put in the work. If you have any questions or difficulties, let me know. Tomorrow we're extending this lesson into part 2, which is going to get into infinite discontinuities. All right, I'll talk to you later.